Venus is, at first glance, a beautiful planet. Smooth, bright, wrapped in soft white clouds like a blanket. From a distance, it's easy to see why the ancients named it after the goddess of love. But go beneath those clouds, and everything changes. Scorching temperatures, crushing pressure, active volcanoes, an atmosphere laced with acid. There are few places in our solar system more hostile than the surface of Venus. And yet, this planet was once, very possibly, a world like ours. And then something went wrong. Something catastrophic. Something that turned an Earth-like world into the most hostile surface in the solar system. Today, we're going to witness the story of Venus, to understand how a planet that could have harbored life ended up like this, and more importantly, whether Earth could one day face the same fate. Venus is the second planet from the Sun. It is our closest neighbor in the solar system. It's roughly 95% the size of Earth. If you were standing on Venus, gravity would feel almost identical to home, about 90% of what you're used to. By every basic measurement, Venus is the most Earth-like planet in the solar system. That's what makes it so disturbing. Because beneath those smooth white clouds is an atmosphere 90 times denser than Earth's. If you could somehow stand on the surface, the pressure pushing down on your body would be equivalent to being 900 meters underwater. The kind of depth that crushes submarines. The kind of pressure that requires specially engineered vessels just to survive for minutes. And that's just the pressure. The atmosphere itself is another problem entirely. The atmosphere is made almost entirely of carbon dioxide. No oxygen, no water vapor. Just a thick, suffocating blanket of gas, and above that, clouds of sulfuric acid moving at 360 kilometers per hour. Not water clouds, acid clouds. And here's what makes that worse. Those clouds are what make Venus look so bright and beautiful from Earth. They reflect about 70% of all sunlight that hits them. Venus is the brightest object in our night sky after the Moon, not because it's close, but because it's covered in a reflective layer of concentrated sulfuric acid. Every time we've looked up and seen that brilliant white light near the horizon, we were looking at acid. But acid clouds are not the only thing unusual about this planet. The temperature is just as strange and just as brutal. The surface of Venus is 465 degrees Celsius, on average, at all times. To put that in context, the surface of Mercury, the planet closest to the Sun, the planet that bakes in direct sunlight with almost no atmosphere, reaches about 430 degrees Celsius at its hottest point. Venus, which is farther from the Sun and covered in clouds that reflect most of the sunlight away, is still hotter, consistently, day and night. This is the greenhouse effect taken to its absolute extreme. The thick carbon dioxide atmosphere traps heat with extraordinary efficiency. Sunlight that manages to penetrate the cloud layers reaches the surface, warms it, and then has nowhere to go. The energy cannot escape. It bounces back up, gets absorbed by the atmosphere, and is radiated back down. The planet essentially became a sealed oven billions of years ago, and it has never cooled since. If you were standing there right now, you would not simply die. Every system in your body would fail at once. Your lungs would collapse from pressure before the heat even reached your core. The sulfuric acid raining down from above would begin breaking down exposed materials within minutes. And it's not just the human body. Even our most advanced machines struggle to survive there. No spacecraft has survived on the Venusian surface for more than 2 hours. Not one. And scientists built those spacecraft knowing the conditions. They engineered them specifically to withstand what Venus throws at them. They reinforced the hulls, pressurized the interiors, used the most heat-resistant materials available. And Venus still destroyed every single one of them within 127 minutes at best. But the state of Venus today is only half the story. What we know about Venus's past should change how you think about this planet entirely. About 4.5 billion years ago, When the solar system was young, Venus almost certainly had liquid water on its surface. The sun was cooler then, roughly 30% less luminous than it is today. Models of early Venus consistently show that temperatures were low enough and the planet's distance from the sun was far enough to support oceans. Venus may have had oceans for up to 2 billion years. 2 billion years. That's longer than complex life has existed on Earth. And then everything changed. Then the sun brightened. As stars age, they gradually increase in luminosity. As the sun grew hotter, Venus absorbed more energy. The oceans began to evaporate. Water vapor entered the atmosphere. And here's the mechanism that sealed Venus's fate. Water vapor is itself a greenhouse gas. As it accumulated in the atmosphere, it trapped more heat. More heat evaporated more water. More water vapor trapped more heat. A feedback loop with no natural break. The oceans boiled away completely. What remained was a planet stripped of its water, left with nothing but carbon dioxide and volcanic gas. Venus didn't start as a hellscape. It became one. Slowly, then all at once, through a process called a runaway greenhouse effect. And what's beneath the surface today tells us it's not finished yet. Here's something that should surprise you. The surface of Venus is surprisingly young, somewhere between 300 and 500 million years old. We know this because it has very few impact craters. On a geologically dead world, craters accumulate over billions of years, creating a heavily pockmarked surface like the Moon's. Venus doesn't have that. Something resurfaced the entire planet in the relatively recent past. Something enormous. The leading hypothesis is both fascinating and terrifying. Venus doesn't release its internal heat gradually, the way Earth does through plate tectonics. Instead, it holds it in. For hundreds of millions of years, pressure builds beneath the surface. And then, all at once, it lets go. The crust cracks. Massive volcanic eruptions sweep across the entire planet. Everything is buried under fresh lava. The surface is completely reset, as if it never existed. The last time this may have happened was around 300 million years ago, which means Venus is approaching another one. Imagine standing on that surface while the ground beneath you is cracking, lava is flowing in the distance, and the sky above is a soup of acid and carbon dioxide at 465 degrees. That is Venus. Throughout history, we have sent many spacecraft to study this planet. The European Space Agency's Venus Express orbited it from 2006 to 2014 and confirmed the presence of lightning in the Venusian atmosphere. And long before that, in 1970, the Soviet Venera 7 became the first spacecraft in history to successfully land on another planet and transmit data back to Earth. It survived on the surface for 23 minutes. But what truly unsettles us about Venus is not how strange it is. It's what that strangeness means for us. Earth and Venus formed at roughly the same time, from the same material, in the same solar neighborhood. For at least some portion of their early history, they were remarkably similar. And then they diverged, completely, irreversibly. The question scientists cannot fully answer yet is, why? Why did Earth develop plate tectonics and Venus didn't? Plate tectonics does something crucial. It recycles carbon. It locks it in rocks, releases it through volcanoes in controlled amounts, and keeps the climate stable over millions of years. Venus has none of that. No carbon cycle, no regulation. And here is the part that should stay with you. The sun is still brightening. Every billion years, it increases in luminosity by roughly 10%. In approximately 1 to 2 billion years, the conditions on Earth will begin to resemble what Venus experienced before its runaway greenhouse event began. The oceans will start to evaporate. And that is exactly why we study Venus. We study it because it is the clearest picture we have of where Earth is going. A world once capable of sustaining life, now locked in permanent, unbreakable heat. Not because of a meteor, not because of a catastrophe from outside, because of physics. Venus has been there for 4.5 billion years. Every clear night, you can find it near the horizon, brilliant, beautiful, and utterly hostile. A world that once had every chance. A world that lost everything to the same physics that governs our own planet. The brightest thing in our night sky is not a star. It's a warning,